So today, what I'll try to do is, so if you try to remember in our last class, we have seen a simple plot, and we try to change the fonts as well. So here CLF is the command that is used for clearing the figure window, the present figure window. I'll show the graph that we have done in the last class. I'll just open the temp file and I'll show it to you. What have we done? So let me quickly, yeah. So in the week 2, if I'm not wrong, yeah, we have taken a vector x and y, and then we try to plot x and y. And you see, this is the defining the line width. This is defining the font size, and set GCA font size to 18 will be indicating you the tick marks. The tick marks, whatever you are going to have, those also will be in font size 18. So for your understanding, I'll run this once again and I'll show the graphs once again. So this is the plot and this is the stem, and this is the title. For title, we have considered the font size as, you can check it out over here, font size is 18. So this example plots, the font size is fixed as 18. Next, y label, x label, font size 18. You can have it here, y label, x label, this is also font size 18. And if you don't use this 18th line set GCA font size to 18, then these values, values in the sense x-axis tick marks 1, 2, 3, 4, 5, whatever you are going to have, those may not be in the font size of 18. For suppose if I try to comment that, let me do this thing over here. Control R will try to comment a line. Control R. So for plot, I just removed this. That means I made this as a comment. So now you can check it out. So this is for the stem plot, and this is the plot using the command plot. You can check it out. The x-axis, the tick marks 1, 1.5, 2, 2.5. The font size is a little less as compared to this one. So whenever you are going to write a thesis, or whenever you are going to save this image in your thesis, you straight away go to edit, and then you go just copy figure. I'll do it once again, edit, and then copy figure. So, and you just try to open one new Word document. For the time being, I'll show it to you. Word document, you just open it and then you paste it. No need to take the print screen. Even the quality also will get disturbed if you try to take. Yeah, this is the nice figure what you are going to have. And if you try to remember, this is this we have done using the white background. If you want, you can even change the background of this also. But when you are going to copy the figure, only these things will get copied, and hence you have been up in this one. Let me try first the continuous plot as well. Let me edit and then copy figure, and then let me move on to this one. Yeah, you can check it out. See, having these tick marks, this font size good, big font size over here, big font size over here, will helps to have a very good display in the thesis whenever you're writing the thesis. Okay, so that will give you a good if you try to look into this, yeah. So this program, whatever I have done as of now, will helps you to Control T will makes the commented instruction again active in the sense it will be uncommented. Okay, and then you can have a look on this. Okay, yeah, someone is trying to type something if I'm not wrong. Yeah, nothing like that. Anyway, now I'll be continuing this ahead now. What I'll try to do is, let me delete this too also. Let us try to have a 3D plots today. So, hemisphere. Let us try to plot. So, a sphere, half of the sphere we will try to plot. So, let me define a vector. Okay, let me define x is equals to, let me consider it from -1 to, let me have a 0.1 increment up to +1. So that means here you are going to have a vector x which is starting from -1 and then -0.8 and then -0.6 and then -0.4. Likewise, it will go up to 1. Okay. Likewise, let me define y is equals to -1 to, again, if you want to me to have -2, yeah, I can do that also. -2 to 0.12. Let me take +2. Okay. Now you try to okay, fine. Yeah. Let me put. So okay, you look over here. I would like to define the x value ranging from -1 to +1, and then y values ranging from -2 to +2, and z is on the y-axis. You can check it out. The horizontal axis is the y-axis, and the one which we are going to have in this direction, the little pinkish color, this is x-axis. So you can check it out that I can consider this as origin 0, 0, 0, and this is let me assume this is positive x-axis and this is positive negative x-axis, and this is positive y-axis and negative y-axis. So I'll be considering y-axis of -2 to +2 and x-axis of -1 to +1. So now what I would like to do is at x is at the coordinate 1, 1, 1, 1 means x is equals to 1 and y is equals to 1. So let me assume, if, for suppose if y is also between -1 and +1, let me assume that this is 1, 1. So at this particular point, what is the amplitude that I am going to have? Okay, so that defining a vector itself doesn't sufficient to define all the coordinates in the grid. What I mean to say is we need to have each and every possible combination. Each and every possible combination means when x is equals to 1, when I try to take x is equals to 1, I would like to find out all values where x is equals to 1. All values where x is equals to 1 means you can check it out here. Here x is equals to 1. And here is also x is equals to 1. Here also x is equal to 1. Here also. So to get all these coordinates, that means I need to map this x is equals to 1 to all the values of y. So let me consider 1, 0, 1, 0.2, 1, 0.4, 1, 0.6, 1, 0.8. Likewise, for the fixed value of x, we are going to have a vector of y. Likewise, now if I move from 1 to 0.8, for that means we were supposed to have a matrix now. Once we define a matrix, and for those x and y values, you can be able to define the magnitude, and that you can able to plot. And for that reason, we are going to have this thing. So minus xca2 plus delta x2 xb. So now I have taken minus xc in the sense, actually, let me move on to the MATLAB now. So instead of this, I can let me use a dx and a dy, and now I'm going to have x space y, okay, is equals to mesh grid. Mesh grid is the command that is going to do this task. Mesh grid, grid, mesh grid, dx comma dy. Let me put this is dy I want to give. So dx comma dy. So now if you try to see, let me execute only these first two lines. So evaluate the selection. So dx is a 1 by 21 vector, dy is 1 by 21 vector, and we try to check it out what is the size of the variable x and y. And before doing that, let me write these instructions. So clear, cros equals all, and then clc. I'm going to save this, and then yeah, week 3. Let me put week 3 save, and then I'm going to run this. Okay, now you can check it out. X is a two-dimensional matrix. X is a two-dimensional matrix, and Y is also a two-dimensional matrix. And remember one thing: what actually is being happened is when X is -1, you just check the first column. When X is -1, Y is going to take all the values. Y is -2, -1.9, all the values it is going to take. 0 up to 2 it is going to take. So the way how I explained earlier, so for each value of x, we have to get it mapped to all y. So that thing is going to be happen here in this matter. So the mesh grid is going to do that one. Mesh grid is going to perform that task. So now once we define the values of x and y, that means x is a two-dimensional matrix, y is also a two-dimensional matrix. In other words, what actually is happening is, if you try to see this thing, you are going to have the x values. So here, for suppose you 1 2 3 1 2 3 and here 1 2 only. So let me consider this is 1. So this is 1 means x is going to have the values, x is going to here all the ones 1 1 1 1 1 1 1, and here you will be having the values of x. Let me consider 0 0.8 0 0.8 0 0.8 0 0.8 0 0.8 0 0.8, and here, whereas if you move on to the y is going to have 1 here. So 1 1 1 1 1 1. So such matrices were being generated using the command mesh grid. So the purpose of using this thing over here is, you can check it out. Best practice is to separate output variables with commas. So because it is giving me a suggestion, let me incorporate that thing. Okay. Better try to avoid all those red marks in the image. Okay. Now, for these x and y values, you will try to define some function. Whichever the function that you would like to have, you can. Okay. For the timing, let me see what was being defined over here. So once we define the mesh grid, so he has taken -1 to 1 and -2 to +4. So you can able to define whatever the coordinates that you would like to have. And yeah, we will try to come to this point a little later. For the timing, what I'm going to do is, let me define some r is equals to, let me assume r is equals to sqrt. Sqrt means the square root of x dot square plus y dot square. Okay. Now what I try to do, you check it out. X is a dimension of 41 by 21. Y is also a dimension of 41 by 21. Each and every element I'm just going to square it, and then I'm going to add it, and whatever the result I'm going to get, I'm going to take the square root of that, and then I'll be substituting in the value of r. And now yeah, let me run this thing. Okay, before going to that, I'll just try to do one thing. I'll go to the plots here, because I can able to do the things very easily. So dx is a vector. What actually dx consists of? Dx consists of a value ranging from -1 to +1. So if I try to just have a simple plot by clicking on it, you can check it out. Dx is going to have values ranging from -1 to +1, -1 to +1. As I told you, y-axis, x-axis, it will be taking the default index. X-axis, it will be taking the default index. Okay, so in the similar manner, you even can plot the dy also. Let me try stem for this dy. So if I go with stem, yeah, I think it is over here. Where is the stem? Yeah, stem. Yeah, this is also. So it is ranging from -2 to +2. You can check it out. -2 to +2. Okay. Now it is because these are one-dimensional vectors. Now when we try to move on to the two-dimensional vector, this is a 41 by 21 vector. And because 2D vectors you can have, okay, which one you want me to select? Yeah, actually what I would like to do as of now, what I thought of doing is, I thought of showing this image. So you people might not know much about this thing. Image essay, I can do it. Yeah, you can assess something from here. Image essay. What I can able to assess over here is, each and every intensity value represents one number. You see, this is a complete. -1 is given as deep dark blue, and 1 is given as pretty yellow. Complete high brightness you are going to have. So you can able to check that all the values in this particular row or in this particular column are same. All the values in this particular column are same. That's what you can able to assess. Whereas if you try to check it out using y, and if I try to move on to image SC, yeah, image SC, it is a horizontal in action. So you just try to compare these two things. Now, what I am trying to do, I'll run this one, square root of x square plus y square. Okay, let me run this. And yeah, editor, sorry, run. So we have obtained r also. R is also a two-dimensional matrix. R is also a two-dimensional matrix. For each and every value of x and y, you will be having one number. I forgot to show this thing. When I press X and if I go to plots, I even can make use of the this also. I can make this. So you can check it out. This is a 3D plot. 3D plot. You can check it out. This is a 3D plot, and actually this is the 3D plot of X. X in the sense. See how this 3D plot of X is going to be taken place. What is X axis? What is Y axis? Anyway, let me do one thing now. So now I'll try to put a surf x comma y comma r. I'll check it out. Yeah, once let me run this now. And let me check this thing. So at each and every x and y value, what is the value of r you are going to have? Can I put this thing? X label, x coordinate. Let me put x coordinate, and the same thing I can even write with y label, y coordinate. And we are supposed to even do the z label also. And z label, if I am not wrong, I should write here radius. Can I call it as radius? Radius 1. Yeah, actually this is z label. You can check it out. So this is x-axis, this is y-axis, and this is the radius what you are going to have. Okay, let me check xy view. Xy view means okay, xz view and yz view. So how to get the negative terms over here? Because the square root will be giving both the positive and negative terms, right? As square root of x square plus or minus you are going to have, right? So how to make that thing now? So x is 41, 21, 41, 21. I just want to complete this split actually. Yeah, if I put here 1 instead of 2, if I put here 1 instead of 2, yeah, this will be good enough. So when x is equals to 0 and y is equals to 0, you are going to have the r value 0. That's what you have seen over here. When x is equals to 0 and y is equals to 0, you are going to have the r value. See, now we will be doing the gradient for this function. So actually what gradient will do is, it will help you to identify how the function is being varied. Okay. Yeah, it is possible to have the contour plot for R also. Contour plot means it will be something like this. Yeah, this is the contour plot. This is the contour plot. What it represents, contour? Yeah, 3D contour. I'll just show it to you. 3D contour. Yeah. There is something like 3D contour. Yeah, this is what. Yeah, you see, yeah, if I click here, x is equals to 9, y is equals to 10, level 0.02. See, actually the shape of the curve is moving upwards, and it's the surface. Actually, the surface is moving upwards, and if I try to have a contour plot, you will be having the circles in the sense that the surface is being encircled at a specific radius value. So this is one value, this is one level, this is another level, this is another level, what we are going to have. Okay, so if you want to increase the number of these circles also, you can increase. That's also possible. If I am not wrong, I think contour 3 R r comma some 10. If I'm not wrong, I think it will work. Yeah, I think we are going to have 10 circles now. 1 2 3 4 5 6 7 8 9 and this yellow one is 10. Yellow one is 10. You can even increase the number of circles that you are supposed to have. Let me put 20. So yeah, so actually this is the shape of the curve. And remember one thing, if you try to look into this, if I calculate the gradient for this function, the function is being is growing. Actually, what gradient will say? Gradient will say that gradient will help you to identify how the function is being graded. Actually, for the scalar, this is the scalar function. R is equals to square root of x square plus y square is the scalar function. Okay, so you do have the vector functions also. Okay, as of now, gradient, if you would like to calculate, gradient will be calculated for a scalar functions. Gradient will be calculated for a scalar functions. Okay, before going to that, let me move on to the presentation. So here, what he is trying to do is, earlier we have taken x square plus y square under root whole to the power of 0.5 he has done. Instead, we can use we can use SQRT also. Now, you check that the dot square is we have done because this x is a matrix. And now you check it out, the origin of the circle, y is being added with +1. So now that means the circle is going to have an origin 0, minus 1. So this is one r value they are taking, and then he is going to calculate z is equals to 1 by r. He is calculating z is equals to 1 by r. Okay. Next, he is trying to use the surf x comma y comma z. Okay. So shall we try that thing? And he is going to view this surface image in a specific coordinates in the sense minus 35.5 to 90 of the x coordinate minus 35.5 to 90 to 30, and he is taking a specific value of y, that y is 30. Okay, fine, let me do that thing over here. So y is being added with +1, y +1. Okay, so now after calculating this r, he is going to calculate z is equal to 1 upon r, and then we are going to have this function surf x comma y comma r. Let us try to check it out how it will be. Editor, I'm just running this thing. Yeah, line 13, z is equals. Yeah, could you please can someone suggest what might be the error? Because what I am supposed to do to nullify this error, matrix dimension must agree. Error in the INSW, INS week 03, line 13. Line 13, there is some error it is showing. So can someone suggest what should I write over here? Anyone in the participants? Actually, here R is
One
a
dot,
vector.
sir.
Yeah, very good. Yeah.
One dot.
Very good, very good. That's really appreciation. Yeah, now I'm running this thing. Yeah, I can check it out. Yeah, here is a icon rotate 3D, and this is what you're going to. And the problem what I have done over here is I haven't chosen the values of x -1 to 1 and -2 to 4. And he is going to have the increment 0.1 here and 0.4 here. So let us try to take the same thing over here, -1 to 1. So -1 to 1, and I think x-axis is okay. -1 to 1, 0.1, x-axis is okay. -2 to 4, -2 to 4 with 0.4 as increment. So the deep value is going, that means the minimum value is going to occur at a place where minimum value means obviously this will be 0. Where it will be 0? When y is equals to -1 and x is equals to 0. When y is equals to -1 and x is equals to 0, this will goes to 0. So if you want to check that thing, that also you can check it. So let me move on to xy, xz. Yeah, here you can check it out. When I think I can use this thing. So when x is equals to 0 and y is equals to -0.8, you are going to get z is equals to 0.2, and x is equals to -0.1, y is equals to You can even check with when x is equals to 0 and y is equals to minus 1. Y is equals to minus 1. X is equals to 0 and y is equals to minus 1 means, so x is equals to 0, where it is occurring? It is occurring in the 11th. Okay, 11th, and y is equals to minus 1. Y is equals to minus 1 means, yeah, where are the y values? Y is equals to minus 1 is going to, actually y is not taking minus 1, actually. You can check it out. Y is taking the values minus 0.8 and minus 1.2. So y is not taking the value minus 1. That is the reason why the minimum value is not 0. Instead, we have seen it as something else in the image. Okay, let me rerun it over here and I can show it to you. Yeah, I think, yeah, z is yeah, let me move here. Z is 1 point. Okay, instead let me move on to xy, xz, and then yz. Okay, so if I try to put my data cursor here, I'll be getting the values. So z is 0.2. Z value, that means r value we are not getting. R value we are not getting 0 because y value it is not taking the value of minus 1. Instead, it is going to take minus 1.2. It is taking at the same time. It is going to take a minus 0.8, but there is no minus 1. That's the reason why we are not getting the curve that is being touched over here. So if you want me to do that thing, I'll put here 0.2. Check it out now. Now absolutely you'll be getting a value that is being touched in the ground. Okay, let me check it out. Y value. Yeah, you can check it out. At y coordinate value minus 1 and x coordinate value 0, you are going to have the magnitude value 0. Okay, so anyway, so he has defined this thing, and let me move on to now he would like to check it out between the x values ranging from minus 37.5 to 90 and then 30. Yeah, let me check what actually is this. So what I am getting over here, I think it is the angle that it is showing. Anyway, we'll check it out what actually this is doing in this subtitle, or you people can try it on your own what this is doing. Okay, so now, so another action he is taking, another R1 he is defining. R1, R2 both were taken, and 1 upon R1. 1 upon R1 means, you check it out, R1 is under root x square plus y minus 0.5 whole square. So that means 1 by x square plus y minus 0.5 whole square, and 1 by x square y plus 0.5 whole square. So you are going to have a curve something like this. So at x is equals to 0 and y is equals to plus 0.5, you are going to have 0, no doubt. And x is equals to 0 and y is equals to minus 0.5 will be, the function is going to have zeros, and of course it is going to have infinity values. So a nice curve you are going to get over here. Okay, that I will try to do it now. Okay, so let us try to copy these things. Yeah, this command prompt is not required because we are running the program in the editor window. Or if you want me to run in the, and let me put here section 2, section 2, okay, and then okay. When we calculate the gradient, now we are going to do the gradient now. Gradient is a vector. Okay, now let me run this section alone. Just run the section alone. Okay, for the time being, let me control off. Yeah. So I'll try to do one thing. Instead of this, the V is the final result, right? I'll try to take this and I'll go to this. I'll just use the surface term. You check it out, the curve is not that much smooth. So to make this smooth, I'll try to reduce the increments here. So instead of minus 0.2, I'll put here 0.1 and here 0.2, I'll put here 0.1. And let me run the section alone again. And you can check it out. The curve might be a little bit more smooth as compared to that of the previous one. And I can do this with the surface plot also. Surface, and you can check it out how the curve is going to be. Okay, so yeah, let me XY view. So there are holes here, YZ view and XZ view. Okay, before going to the before going for the gradient, you try to observe this thing. What I want you to observe is, you check it out where the function or the scalar function is varying more, where the scalar function is varying more. So remember one thing, other than this positive peak and the down negative peak, the remaining places, maybe in this particular region, you don't find the function is being variant, because when you try to calculate the gradient in this particular direction, in this particular area, you'll be getting 0. When you calculate the gradient will be having both magnitude and direction. Magnitude will be indicating you how much the function is going to vary. If the function is having a very steep increment, then you are going to have the magnitude of that particular vector very, very high. If the function is going to have very low variations, that means if you try to check it out, the curve maybe at this particular range, you see near my cursor where I am keeping, in this range, the curve is, the function is very slowly varying. And if you try to calculate the gradient over there, the gradient will be having a vector which is going to have very small magnitude, because the vector magnitude will be indicating you the way how the function is varying. If the function is varying slowly, the vector magnitude will be low. And then the direction of the vector will be showing you in which direction the function is going. These 2 points are more important. The gradient vector direction will be giving you the direction at which the function is going, whereas the length of the vector will be helping you to identify how much magnitude variation you are going to see in this particular direction. Okay, anyway, it is there in my presentation. Let me complete that, and afterwards you can able to do that thing. So anyway, this color map is just changing the color. So if you would like, there are so many color maps. Okay, now here V is a two-dimensional vector, two-dimensional matrix for that matter. I'm going to calculate the gradient vector now. So what is this 0.2 and 0.2? What are the second two, or what are the other two arguments? We can able to check it a little later. Once we complete this task of plotting this. Okay, when we calculate the gradient, we are going to get two arguments, Ex and Ey. Ex and Ey will be giving you the component in the x direction, component in the y direction. Okay, component in the x direction, component in the y direction. So component in the x direction, how much component is there in the x direction, how much component is there in the y direction. So if you try to pass this quiver Ex and Ey, you can check it out in which direction the function is going more. Okay, let me take this and run over there and let me show it to you. Okay. Editor, I'm just running it. I should not have done this thing. Run this section. Yeah, some mistake is being happened or what? Am I in the right place? Okay, gradient B. Okay, let's run this thing over here. Why is so? Okay, let me do one thing. I'm not getting what I'm expected. Control R. I'll just run. Yeah, game is over. Let me run up to this one. Run to cursor. Yeah, very nice curve I have obtained. And then I'm just calculating the gradient. Run to cursor. Ex and Ey you are going to have. Ex is again a two-dimensional matrix. Ey is a two-dimensional matrix. Ex will gives you the component of the vector in the x direction. Ey gives you the component of the vector in the y direction. And then we are going to have run to the cursor. So I think a quiver is not working. Yeah, quit. So why this quiver is not working? Let us try to check it out. Control C, Control V. I just want to have 3D rotation. Quiver. Let me check it out over here. Yeah, you can check it out now, at least here. Yeah, just try to observe this particular image. Okay, so this particular image says that if I try to consider this, yeah, let me. Okay, I think I'm not in a position. Okay, fine. This is a quiver will helps you to plot a vector. Quiver will helps you to plot a vector. At which location you are supposed to plot? At x comma y location. So x comma y we are going to define. At each and every x comma y location, you are supposed to plot the vector, and u comma v will be giving you the component of the vector in the x direction. U will be giving you the component in the x direction, and v will be giving you the component in the y direction. Okay, so that means the function, you see, the function is going to have more variation in this particular direction. Let me show this thing to you at least. Yeah, let me understand. I don't understand why that quiver is not working there. Let me take this. So save. Okay, cancel. I think it is not accepting the brackets. Anyway, let me put 3 underscore 2. Yeah, before going to that, what I would like to show to you is, let me plot z value. Z value plots. Let me go to surface. Yeah, surface. Yeah, you can check it out now. So this is a curve. This is a curve what you are going to have. Okay. So more or less similar to that of the earlier one, but this seems to be a little bit more smooth. If you want to have more smoothness on here, I can even increase the use 2.05. Let me take, and here also 0.05. Let me take, and then let me comment these things. Control R, and let me straight away move on to surf surf x comma y comma and then z. I'm just plotting the surface. Okay, and then editor, let me run this thing. Something mistake is there. Yeah, I believe they have used capital X, and even this is capital Y, and this is capital Z. Okay, land, and you can see very nice smooth curve you can able to see. One point what you can able to check it out in this particular figure is this surface is going to have very slow variations at the bottom. Now if I try to move towards the top from this particular location, let me move on to this particular location in the top. So you can able to say that the function is going to increase more and more and more. But at the edges, there is no functional variation. If you go down, the function is being varied. Here also the function is being varied, but it is going down. Let me show X value. X, yeah, you can check it out now. Y, Z. Okay. Now for this particular case, if you would like to plot the contour plot, actual contour, you will be getting a two-dimensional contour. Let me use figure again here. This figure. This is two-dimensional contour. You can have even the three-dimensional contour also. So for that, I'll be using the same instruction. Three-dimensional contour means you are going to have the same thing over here. Figure contour 3. And let's run here. Yeah. Now if you try to compare figure 3 and figure 1, both results the same. And I even can plot the third figure in the first figure. For that, what I'll try to do is, I don't use this figure now. And let me use figure. I just want to have line width. Let me use line width 3 because it seems to be a little bit more thin lines. Thin lines, I think. Yeah, you can check it out. So fine. Now I'll try to overlap these two things now. So for that, I remove this figure and I'll try to plot this contour 3 and I'll keep it after this. And before plotting this, I'll try to use a hold on command. Okay. Yeah. Now the second one is not required. You can check it out now. So contour 3 and surface both were plotted on the same graph. And you even can plot this contour two-dimensional plot also in this. Which I will hold on. I think this is not the appropriate figure. Let me show it to you somewhere else. So let me put it somewhere over here and let me go to the plots. Yeah, what I mean to say is the figure what I'm expecting over here is something contour 3. Yeah, I have done it. Even in on the ground also it will be plotted. Let me check it out. Hold on, contour x comma y comma z. Let me keep this over here. And let me put it for GURE figure. Form editor run. Actually, you can check it out. It is being plotted over here. You can check out. These are the circles what you can able to have. These are the circles of the contour. Okay, these are the circles of the contour. So even if I try to put here hold on, will hold on, all were mapped over here. Okay. Okay, what I would like to say, what I want to say is the function is being varied over here. Here the function is being varied over here to the large extent, and the edges the function are being varied. Okay, let me move on to this cleaver. Why this function cleaver is not working? Let me check it out. So let me type it over here, and then dx dy. I can even increase the size dx dy. This seems to be very x. Okay, let me not use x comma y now. Okay, quiver 3, let me do it. Quiver 3 is there. That may help you. Actually, I would like to have the reduction in the number of yeah. What I would like to do here is I want to have. Okay, fine. You just try to observe this figure at least. If you try to observe this figure, when the curve is going to the down, actually the left side is the lower dip and the right side is the upper dip. So upper dip means you can check it out that during this positive surface means yeah. Okay, so when you are going to up from this to top, you are going to have the vector size more. You see, the more the vector size means the function is going more, and this indicates the direction at which the function is going. And the moment when it reaches here, more or less a flat is there. So that means all these vectors will be helping us to find out the gradient. All these vectors. So that means at each gradient will be a function, right? When you try to given a surface, I into dou by dou x, I have j into dou by dou y, k into dou by dou z of some function you are going to have. So that means ultimately you are going to have a vector. So in that particular gradient function, you are going to substitute the values x comma y comma z. The moment when you try to substitute the values x comma y comma z, you will be getting a vector. A vector. For suppose if I try to consider x square y, let me assume a function. X square y, if I try to perform I into dou by dou x of x square y, that means I will be getting 2xy. So x component is 2xy, and y component is x square. Because if I try to perform x square y differentiation with respect to y, x square you will be getting, and z it will be 0. So that means 2xy into ax bar plus x square into ay bar. So when I try to substitute x is equals 0 and y is equals 0, then you will be having a magnitude 0 comma 0. That means you don't have any vector, you don't find a vector with the magnitude. The magnitude value is 0, and of course the phase is also, you don't define any phase. Now if I try to take x is equals to 1 and y is equals to 1, x square into y, that will be 1, and 1 into y, I mean 1 into ay bar. So that means 1 into ax bar plus 1 into ay bar. So that is the vector. That vector is going to have a magnitude √2, and the direction is towards the 45 degrees. I am talking about the vector x square y for the function scalar function x square y. So once again, what I want to repeat over here is the length of the vector. Again, I am saying because here I try to plot this thing there. Fever, I am going to have more number of vectors. Let me go this. Yeah. I just want to reduce the vector length here, and number of vectors I would like to reduce. First of all, I would like to reduce the number of vectors. I think I can do that thing. Anyway, let me do it maybe in the next class. The moment when you try to reduce the number of vectors, things will be a little bit clear, and the figure what you may expect is something like this. Okay, so in the direction where you are going to have a vector representation with a more length, that means the function is going to vary more. You see at the edges, you don't find any vectors. That means the function is not at all getting varied over there. And you know the function is varying in this direction. This is lower dip actually. Lower from this lower dip, if I try to move this direction, the function is increasing in this direction, and the function is increasing in this direction. If I try to come over here, this is the upper tip. So if I try to move this, the function is going in the upside direction, but if I try to go down, the function is going to decrease. That's the reason why you're going to have the reverse sign. That means the function is increasing from this direction. The function is increasing from this direction. What I mean to say is, yeah, you can check it out here. The function is increasing in this direction. So that is the reason why the function, the arrow marks were towards this upwards. And if I try to see, the arrow marks of the vectors will be towards this right side, upwards. Here towards right side, left side, upwards. Okay, and here the function is going to be decreasing, so the function is increasing in the downwards. The function is being very downwards, and if you try to check it out over here, you can have the function is increasing upwards. That means magnitude wise it is going to have variation is there. How the function is being varied? In this particular direction the function is increasing. So gradient, the significance will the gradient will specifies you at so and so point how the vector is. You can able to find it out. You substitute the value of the coordinate in that particular gradient function. So once you substitute there, you will be getting a vector length and the direction of the face also. So based on the magnitude of that vector, so in which direction the function is being varied, in which direction the function is being increased, that you can able to identify. And that is exactly what is being indicated over here. Actually, quiver is a command that is being used to plot the vector. So to be more clear, I'll be letting you how to reduce the number of vectors, or here how to increase the number of vectors. I'll try to show it to you in the next class. As of now, if you have any queries, please, I'll stop here.